Well, good afternoon. I know this is the last session, so we'll try and make this as informative and fun as possible. That will very much depend on you and whether or not you have any questions. I was going to suggest you ask questions as I went along, but given that we've got the microphone game to play, we'll wait until the end if you wouldn't mind. My name is Rick Hutley. I'm the Program Director and Professor of Analytics at the University of the Pacific. And I just had a question a moment ago. Where the heck is the University of the Pacific? Well, its main campus is in Stockton, but we also have a campus here in Sacramento, which some of you may know as the McGeorge School of Law. And for what it's worth, we have a campus in San Francisco. So my objective for today is to really try and tell you two things. I want to explain to you what the heck is IoT, big data and analytics. What do those words mean? And sort of explain some of it, because it's a mystery to some people. And the second thing is to give you a few examples, and I mean just a few. There are thousands of examples. But I want to give you a few examples of IoT, big data and analytics, to give you a sense of the sorts of things that can be done. So hopefully my objectives accord with your objectives for being here. So again, thank you for coming. Let's start. What is IoT? The Internet of Things. And the first thing I really want to point out to you is that we are entering, if not having already entered, a whole new era, in my opinion. We went through the Industrial Revolution and the Technology Revolution and so on. In the Industrial Revolution, what fundamentally changed was the economics of life. Suddenly, business economics or success was based upon how well you could master machines. We then moved into the technological age quite some time later, in the mid-1950s, 60s, 70s era. And there it changed again. Now it was all about how well could you leverage technology, and in particular computing, and more latterly the internet. But it was how well could you master technology. That determined your corporate success or your economic success, including governments. But now we're entering the era of data and analytics. And the future success of companies and organizations of all types are going to be based upon how well you can capture, analyze, and utilize data. So we are entering, as I say, if not already in, the data era. That's why there is such interest now on IoT, big data, and analytics. So it's really important to understand that we're in this new age. Let's look briefly at the internet and how it went through various phases. The internet is really young in historic terms. I mean, it's only, what, 16, 17 years old, really? Which is actually very, very new. But think back what it was like before the internet age. I was actually recruited as Vice President of Innovation at Cisco Systems. And I was running around the world trying to explain to business leaders that this new thing coming along called the internet. They'd never heard of it. The internet boom hadn't happened. And I was trying to explain to them that what you really have to have is a website. That's all you need. You have to have a website, because then you're visible to the world for the first time ever. Believe me, that took a lot of convincing. When you're standing in a boardroom and they say, you know, we're a 160-year-old company and we've been very successful, thank you, young man. I was young back then. You know, we don't need this newfangled stuff. It's a fad. Well, we all know it's not a fad now. But it was a reasonable pushback. It was very simple. Simply connect. It was about showing your data to the world. Then we went into what most of us think of when we think of the internet from a business perspective. It was about taking our business processes and automating them. So instead of those paper-based orders that we took with pens and pads, now your customers could go online and place an order. So suddenly the internet became interactive. It wasn't just showing your data, it was now interacting with your customers or your constituents, etc. The third phase was then the people phase. And that's the phase we've kind of just been through. We're still in all of these phases, of course. We still use machines, we still use computers, etc. But this is the age of automating people. So Facebook, Twitter, Instagram, all of the people-related activities we started to automate and put on the web. And if you've done data, processes and people, the only thing that's left is everything else, which is why today it's now referred to as the Internet of Things. Now, there are many, many things, and I give you a thought experiment, to use Einstein's phrase. Most of us in the West think that we are pretty sophisticated when it comes to technology. We think we're pretty connected, right? I don't see in the room here, but usually I've got a laptop, I have a tablet, a smartphone in my pocket, and a smartwatch. So I'm really hip. You know, I've got 4 whole things and I'm ultra connected. But actually we're not very connected at all. Look around you, maybe literally or in your head, sitting in your office, sitting in your home. Look at all the things that are not connected. That's what's interesting. And I'm going to have a figure for that in just a moment. But we'll come back to that. And that's what we're referring to as these things. It's the things in your life that are not connected at the moment, and they're going to be. But these all come together. The Internet of Things in number 1, along with social media, that Twitter, Facebook, all of that. Those are the things that are creating the data, what's referred to as big data. And I'm going to explain what big data means, and it's more than just lots of data. But it creates the data. Data's of no use to you. Data simply provides the ability to get insights, and that's where analytics comes in at point 3. You analyze the data, you perform analytics, and that gives you the insights to make decisions. And ultimately, that's the objective, is to make business decisions. If you don't make business decisions, or personal decisions if you're thinking at home, then what was the point? If you didn't make a decision and act, there was no point. Every decision we make in life is based upon data. If we make a decision without data, it simply means we're guessing. And sometimes we have to guess because we have no data. But ideally, we strive to get data to make decisions. Even something as simple as where should we go for dinner tonight? There's data in here. Oh, I don't like Indian, or I do like Chinese, or I don't like Italian, or I don't like this restaurant versus that restaurant. I mean, this is all data. And who am I going to go to dinner with? You know, what do they like and not like? Anyway, that's the circle of life, if you will. The technology, the things create the data that we perform with analytics to give us the business insights to make decisions. One of the slides, oh, I do have the slide in here. I'm going to come on to it. I said a moment ago that we have a lot of things that are not connected. When I was in Cisco, we actually performed some analysis of that. And what we determined was greater than 99%, in fact 99.4% if you want to be precise, of things that we could usefully connect to the internet are not connected today. So if you look around you, or you think at home or in your office, you know, the book that you're reading is not connected. The pen you're writing with, your glasses, I'm forever looking for my glasses. Wouldn't it be great to pull out my phone or talk to my Amazon Echo and say, where did I leave my glasses? She says, they're beside your bed, you fool. Your clothes are not connected. I mean, everything. Most of the things around you are not connected. These chairs, your clothes, your shoes, everything. They are being connected in their billions, literally, in their billions. Now, I'm going to make a very obvious statement here, but it's a fundamental and important one. If something is not connected, you can't see it. I'm talking about digitally on a computer, and for most of us, if you're trying to run a company, you want to see your company online. You don't want to have to walk around every office and count things. But if it's not connected, you can't see it. You don't know how many widgets you've got. or where they are, or whether they're hot or cold or vibrating too much, or the last time they had maintenance. It's invisible. As we connect things, those 99.4% of things in our world, as we connect them, they become visible to us for the first time ever. And that enables us to make business decisions with much more accuracy. Many of you, I'm sure, are used to the term of routine maintenance. What does that mean, the word routine? What it means is we're not actually sure whether a piece of equipment needs maintenance, so we're, based on history, we're going to perform maintenance on it routinely. Every 6 months, whether it likes it or not, it's going to get damn maintenance. Well, once we can see it, once it's connected, we can make more intelligent decisions. That machine over there is working perfectly fine, leave it alone. This one over here, which by the way is brand new, is really running hot. We need to give that one love, care and attention and leave this one alone. That's a much more efficient way of doing routine maintenance, not routinely, intelligently. That's just an example. So, I said I was going to show you a few examples of IoT devices. Here's the first. I used to ask people, hands up anybody that doesn't have a smartphone. But you know, that's irrelevant nowadays. Everybody has a smartphone. But have you ever stopped to think what that smartphone is capable of telling the world? And I'm not going to run down the complete list. But it's got every sensor known to man. It can see everything you see. It's got cameras front and back. It's got microphones to hear everything you say. Accelerometers, inclinometers, magnetometers, every ometer known to man. Temperature, GPS. It knows exactly where you are on the planet every second of the day. By the way, it knows exactly who you're sitting next to right now, how long you sat next to them, whether you leave this room and go separate ways or you go together. It has the potential to know everything that you do. I refer to this as digital exhaust. We are kicking off more data than you can possibly imagine. Every one of us right now sitting in this room. So what could you do with that data? Wow, you could do an awful lot. But I don't have time to go into that. I'll be happy to take questions afterwards. But just imagine the types of data that's coming off of this device. Every one of your employees is kicking off that kind of information. Most companies have swipe badges that go through card reader doors. You know, we can know where our customers are, our employees are, our competitors are. We can know everything. Digital transport, or creating greater efficiency with transport. This is an example of a company. I don't know if you can see this. The driver here with a laptop in his cab. This is a real example. This particular company, typically drivers used to drive back to headquarters, to their hub, to pick up their next set of instructions, and then they would drive out to the next location where they've got to deliver stuff or do whatever. It was a hub and spoke kind of approach. Very inefficient. By digitizing the cab, the controller could now see exactly where every one of their drivers were across the country and could then send instructions to them, say, don't go to city X like I told you this morning. Let me divert you to city Y first. A, because that's en route to city X if you just take a slight deviation, and you can pick something else up for us along the way. Much more efficient use of the employees and the vehicles and so forth. And a whole bunch of other material coming back about the way the drivers are driving, about the vehicles themselves. There's the famous story, I think it was FedEx or UPS, one of them, who performed analytics and discovered that if they told their drivers to always turn right, regardless, they would get to the destination more efficiently than if they took what GPS said, turn left, turn right, because they didn't have to wait for traffic lights and all sorts of other things. The virtual workforce. This is a mock-up, but these things are coming and certainly could be built technologically. It's perfectly feasible. This is a smartphone that is being used. It says, you can't probably read it, it says virus detected. This was an example of a problem where you want to engage your extended workforce. Maybe that's every employee in your organization. Maybe it's your customers. Or maybe it's the general public at large, and turn them into a surrogate workforce. Imagine a country like China or India, or even some of the central plains of the US, where we don't have enough people to go out to every single endpoint, whether that's a patient or a field of crops or a particular piece of equipment. If we employ technology, we can use, as I say, the public or the extended workforce to go out and do this work for you. Now, they don't have to be experts. This individual here is using their smartphone. They're not a doctor, but the smartphone takes a picture, passes it up to the cloud, where an expert has written a program to analyze that image and determine, is this something a doctor should look at or not? And sends the answer back down to the smartphone almost instantly as far as this person's concerned, and they can say, yes, this is something you should go to the doctor about or not. Or as I say, it could be infestations in a wheat field, it could be a piece of equipment that you suspect might have a problem or not. Smart and connected traffic management. Turning to smart cities, I think I've got another slide on smart cities as well. But again here, using technology to capture the data about all of the various transport mechanisms. I know you can't read the words, but you've got planes and buses and trains as well as roads and so forth. Bringing all of that data together and performing analytics so that you can more efficiently run the transport systems holistically across the entire city or community. It also opens up various other opportunities, as it said here. Electronic payment systems, smart road pricing. You can start to sell space, for example. One of the suggestions I had for this particular city, which will remain nameless, for restaurant owners. Imagine a restaurant owner being able to rent space in front of their restaurant when they're having a particular event, and those parking spaces are reserved for their customers only. People driving through cities spend, I forget what the figure is now, I think it's like 20% of your time, travel time, is spent looking for a parking space. Using technology like smart cities, you can actually tell people on an app, this is the closest parking space for you, and they can reserve and book that using their credit card before they even arrive. Smart buildings in general. This is from a company that puts smart technology into various buildings. You can see the maps here. Now, buildings are interesting. It's the second biggest cost for almost any company or organization. The first cost, almost a third of a company's costs, if not more, are people in various forms, salaries and overheads and so forth. The second, almost the same size, is facilities, it's buildings. It's a huge cost. Most buildings today, the floor plans are way out of date. They're all paper-based for the most part, and they're way out of date. So if there is an incident and the first responders turned up, quite honestly, the paper-based floor plans are worthless. More importantly, is the building up to code? We know it was up to code when we built it, but since we built it, you know, someone knocked that wall down because they wanted an extra office, and they put filing cabinets down that corridor and stored some other stuff over here. All these changes never get captured. So is the building still up to code? Well, if it's digitized, which is what these people are doing here, you can get the technology to tell you. Cameras down that corridor detect that people have stacked boxes there yesterday afternoon. It's no longer in code. There's a fire risk, and so forth. First responders, you put badges on them when they arrive, and you can actually see them walking around the building and direct them using radio to tell them where to go. Another example, intelligent security robots. This is another company, Gamma 2 Robotics. They have these robots that will roam around, whether it's a data center, I think that's the example here, or warehouses, and so forth. Robots not only don't take holidays and all those sorts of things, they can do things that you and I can't. Yes, they've got cameras on, so this one can actually do facial recognition. If it comes across someone in the warehouse, it can determine who is that person, do I recognise them? And by the way, if it doesn't recognise you, it can do things. Yeah, well, it could do that as well, yeah. Taser. Not quite what I had in mind, but I love it. But it can talk to the other systems in the building. So, you know, it can say there's been an unrecognised individual, you know, that can send a message to the security department, maybe to the local police, could set alarms off, lock doors, all sorts of things that it could do. But it has other sensors that we don't have. It can see in the infrared. So first of all, it can detect fire, but it can detect things before they catch fire. That's a hot, glowing thing over there. So perhaps there's a piece of equipment that's starting to overheat. And again, it could take action. It has gas sensors in it. It can detect gas, CO2, depends on the building, but CO2 and all sorts of other things that it can detect. And it's a lower cost of operation than using human beings. So those were just a few examples of IoT. Those technologies, those sensors, some of them really small, incredibly small. In fact, so small you can't see them with the human eye. Right the way up to big things like robots and so on. Those are the things that are creating the data. So let's look at what big data is and isn't. It's not volume alone. It's not just big data. That's part of it. In fact, it's a big part of it. It's unimaginable, the amount of data that we have available to us today. Not just within our organisations or companies, but now we have the ability to pull in data from all over the place, from government statistics, from city data, from local companies and so forth. Social media data, Twitter feeds and so on. So first of all, there certainly is volume. The second is variety. It's what we refer to as structured or unstructured data. Historically, we've dealt with structured data. This is data that fits in what are called relational databases. Think of a spreadsheet. You have, you know, a record, a sales record, for example, and you can neatly put a sales record into a row on a spreadsheet, and the columns are all the same. The date, the amount, the product that was ordered, and so forth. But it fits nice and neatly into rows and columns, and that's what a structured data looks like. But most data today is not structured. Video, for example. Video is not structured. I mean, I understand there's a structure to video, there's a frame and all that. But when you look at the video content, every frame of video is different from any other frame of video ever, and always will be. They're unique. Voice is the same. So the large majority of data that's created today is unstructured. But more importantly, we have this variety of data. It's not just in the past we had our company's data, the sales data, the marketing data, that was it. Now we've got a whole range of data that we can use, and that provides us with a very rich and different perspective on the world. The third is velocity. Historically, data came to us usually, historically, it was in the past. And what you did is you reported on the past. This was last month's sales figures. And you did your best to guess at what next month's sales figures would be based on the past. This was last month's sales figures. This is what those sales figures were for that month a year ago and the year before that. And you try and project a trend line and predict what next month's sales figures are likely to be like. But it's all based on the past. Today, it's mostly real time. Think of a security camera. There are hundreds of them in every store you walk into, all in the ceiling, in that black ceiling. They are capturing 30 frames a second in real time. Twitter is almost real time. But it's not batch, it's not historic. So the largest proportion of data now is real time. And finally, venue. Data is created and captured and needs to be processed locally. Okay? I'm going to come to that in just a second. By the way, there's a little throwaway fact there from Goldman Sachs. 90% of the world's data has been created in the last 2 years. Think about that. 90% of the data that we have available to us, which is unimaginable, was created in the last 2 years. I can't remember when I got that quote, but it's certainly out of date now. Actually, it was out of date before I finished typing it on the slide. Sorry. It's unimaginable. But it's all about actionable insights. So what do we need to do with this data? And this is, again, for the managers in the room. What do you do with all this big data? How do you handle it? The first thing you have to do is capture it. Okay? You've got sensors out there. If something is not visible to you, go put sensors on it. Go instrument your world so that it's creating data and now you can see it. Okay? And if it's of value to you, you'll do that. But capture the data. But then you need to merge or consolidate the data. You don't need necessarily all of the data that's available. Think back to that security camera. 30 frames a second. You don't need 30 frames every second. You don't need 30 frames every hour. You need the 30 frames at 2 a.m. in the morning when something walked across the parking lot that shouldn't be there. Those are the 30 frames you need. So, you need to consolidate and select the data that you need. Third, you need to analyze. And increasingly, you need to analyze locally. Because ultimately, you need to act. So again, go back to that security camera. I don't want to even capture the 30 frames a second at 2 a.m. in the morning and send it to the data center to be processed in the batch process tomorrow night, and then a signal comes back to me saying, yes, that person shouldn't be there, take action. Well, it's too late. I need to take action locally. So those are the 4 steps, if you will. Capture the data, consolidate it and select that which you need, analyze it to determine what actions you need to take, and then act.